Want to welcome you all to our online study where we will be looking at different concepts in mathematics and possibly try to demystify them and make them simpler. For those of my friends that don't like mathematics, I promise to make mathematics simpler for you. Today we'll be looking at some exam questions, 2018 WASSCE question. We'll try as much as possible to go as far as we can. Then by the end of the day, we'll see how far we can go. Then possibly in the next episode, we can continue from where we stopped. I have a question I would love to start with. From my last video, one of my friends was asking how I got 6/5 as an answer, and I converted to a mixed fraction to get 1/5. In actual sense, he was trying to say, how did I convert my improper fraction to a mixed fraction? The idea is, if 5 divides 6, we have 1 remaining 1 over 5. Other examples of that could be 12/5. Assuming I have 2/5. 5 divided 12 is 2. Then of course 2 is remaining all over 5. So assuming we have maybe 19/4 to convert to mixed fraction. In this case I have 4 divided 19 should be 4. That is remaining 3/4. And the maths 4 para. I hope you've understood how we got 6/5 to be 1/5. Then we'll go straight to our questions, and we would love to look at this day in this class. We're looking at the objective question of the senior school certificate exam, WASSCE of course, 2018. I would love you to share this video as widely as possible. We'll try as much as possible to be slow, so at your own pace. Of course, you can rewind, pause it, go forward, go back till you get a particular question before you get to the next one. You can always ask me questions, possibly through my email address, talk to Unkle@gmail.com. Talk to Unkle@gmail.com. Talk to Unkle@gmail.com. I promise to respond to every of your questions. And if there are questions and comments and maybe other things you would love me to, maybe questions you would like me to tackle apart from the ones I bring up, then you can always send them to my email address in my inbox. Then I can always treat them in the next episode. Alright, let's start. First question number 1 of 2018 WASSCE says simplify. It says solve question 108 plus root 125 minus root 75. We are told to simplify root 108 plus root 125 minus root 75. In this case, we have, of course, this is 36 times 3. 36 times 3, of course, when we want to work with source, we have a good understanding of perfect squares. We are trying to break these numbers down into perfect squares and possibly irrational numbers that will come out of it. So the perfect square that we have here will be 36 by 3 plus 125 should be 25 times 5 minus 75 should be 25 times 3. So in that case, I have square root of 36 should give me 6 root 3 plus square root of 5. Square root of 25 is 5 root 5 for this, minus square root of 25 of course is 5 root 3. In that case, I'm collecting like terms now. We have root 3 here and I have root 3 here, so of course I'm collecting this for this. So I have 6 root 3 minus 5 root 3 plus 5 root 5. Then I have 6 minus 5 of course is 1, so I don't need to write 1, I simply write root 3. Of course 6 minus 5 is 1. 1 root 3 is same thing as root 3. So plus 5 root 5. So in that case we have that root 108 plus root 125 minus root 75 finally gives us this. Remember I said you can rewind the video, look at it at your own pace, analyze it. If there are confusions, you can get back to me in my inbox. Alright, we go to question number 2. Remember we're dealing with 2018 WASSCE Mathematics question objective part. Question number 2 says we should evaluate 64 1 over 2 raised to power 1 over 2 plus 125 raised to power 1 over 3 all raised to power 2. Evaluate 64 raised to power 1 over 2 plus 125 raised to power 1 over 3 all raised to power 2. Of course, there is the law of indices that says if I have x raised to power 1 over a, it will now be a root x. Meaning that in this case, I will have the second root of 64 plus, of course, the same rule applies here, the third root of 125. The third root of 125 all raised to power 2. Second root of 64 is 8 plus third root of 125 means 5 times 5 times 5. 5 times 525 times 5 will give us 125. Meaning that the third root of 125 is 5. Then we raise to power 2. In this case, I have this plus this will give me 13 all raised to power 2. Of course, if you're good with your perfect square, you know that 13 squared will give us 169. Of course, if you're not that good, you have just to press 13 times 13 on your calculator. So you can simply say 64 raised to power 1 over 2 plus 125 raised to power 1 over 3 all square will finally give us 169. Is that okay? Okay, we take our third question. It says, given that y varies inversely, so I can say, given that y, question number 3, y varies inversely. Of course, if it's the direct proportion or direct variation, we say y varies as x. This is a direct situation. But the question we want to look at says that y varies inversely as the square of x. So y varies inversely as the square of x. Then we can say y is equals to k over x squared. We say k is the symbol for our constant of proportionality. We call it constant of proportionality. We introduce it at the second level. The first statement says y varies inversely as x squared. Then on the second level, we change our sign for variation to equality sign and introduce our constant of proportionality denoted as what? K. Then they said if x is 3, that means this is 3 now, and when y is 100. So y is 100, then k over 3 squared. They said x is 3 when y is 100. So we put 100 here, put 3 squared here. In a nutshell, we can have that k is equals to k over 9 is equals to 100. I'm just trying to take all the steps necessary. Then we have that our k is equals to cross multiplying, k should be 900. The question said we should find the equation connecting x and y. That equation comes back to this level. This is the equation connecting x and y. All I need to do now is to take my value of k as 900 and put it. So in that case, I have that y is equals to k we got as 100, 900 over x squared. So this is the equation connecting x and y. The equation connecting x and y. Question number 4. Question number 4. Remember we said you can always rewind and look at it again so that I